Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The Hofmann rearrangement, Hofmann degradation, converts a primary amide, R-CoNH2, to a primary amine, R-NH2, with loss of CO2 using NaOCl or Br to NaOH in aqueous base. When applied to a cyclic imide, phthalimide derivative, the reaction opens the imide ring and converts one of the carbonyl nitrogen bonds via Hofmann rearrangement. Step 1. Identify the starting material. The starting material is 4-nitrophthalimide. This is a phthalimide, isondol, 1,3 dione, with a nitro group at the 4 position of the benzene ring. The imide has to C is equal to O groups and 1 NH. Step 2. Reaction with NaOCl H2O. NaOCl in water is the classic Hofmann rearrangement reagent. Under basic aqueous conditions, NaOCl reacts with the NH of the imide. The mechanism involves I. Enchlorination of the imide NH to give enchloro intermediate. 2. Base abstracts the remaining NH proton, already done. 3. Hofmann rearrangement occurs. 1 acyl group migrates, forming an isocyanate intermediate. 4. The isocyanate hydrolyzes in water to give a carbamic acid, which loses CO2 to yield a primary amine. Simultaneously, the other carbonyl, ester acid, remains as a carboxylic acid after ring opening. Step 3. Determine regiochemistry of the product. In 4-nitrophthalimide, the nitro group is at position 4 of the benzene ring. The 2 carbonyl groups are at positions 1 and 3 of the isondol system. The Hofmann rearrangement converts one C is equal to ONH unit to NH2, and the other C is equal to O becomes CO2H after hydrolysis. The carbon bearing the nitro group is adjacent to one of the carbonyl carbons. The product will have NH2 and CO2H groups on adjacent carbons of the benzene ring, ortho to each other, with the number 2 group also on the ring at the position adjacent to CO2H. Step 4. Assign the product structure. The product has NH2 ortho to CO2H on the benzene ring, with number 2 at the position adjacent to CO2H, i.e., NH2 and number 2 are on either side of CO2H, or specifically NH2 at one position, CO2H next, number 2 next. Based on the numbering of 4-nitrophthalimide, the number 2 is at position 4, adjacent to the C3 carbonyl carbon. After Hofmann rearrangement, C1 carbonyl becomes CO2H and C3 carbonyl NH becomes NH2, or vice versa. The result is that NH2 is at the carbon adjacent to number 2 and CO2H is between NH2 and the ring junction, giving NH2 at C1 of the benzene, CO2H at C2 number 2 at C3, i.e., option B pattern. Step 5. Eliminate other options. A. Has CO2H and NH2 swapped relative to the correct regiochemistry given the number 2 position, incorrect regiochemistry. C. Gives a dicarboxylic acid with no amine. This would be simple hydrolysis, not Hofmann rearrangement. D. Places number 2 para to NH2, which does not match the 4-nitrophthalimide starting material connectivity. Therefore, the correct answer is B. Therefore, the correct answer is option B.